If you look at any schematic, you will find many capacitors. Usually the designers indicate only the capacitance value and they don't determine the capacitor type. You know, there are several capacitor types, each with its own characteristics, pros and cons. Aluminum electrolytic capacitors, tantalum electrolytic capacitors, ceramic, plastic, etc. It's confusing to select a certain capacitor type for a specific job in a circuit. In this video, I'll talk about 6 major capacitor types and also answer these critical questions. What is the main difference between capacitor types in practice? What is the difference in their behavior? Where should I use a specific type of capacitor? Along with examples of their usages and many other questions around the subject. Stick around for the full experience. I'm gonna start with this question. Why there are several types of capacitors? It's a great question. Since a capacitor consists of 2 metal plates and a dielectric in between, it has to be a very simple component, and it seems that there is no need for several types. Let me clarify the misconception with a simple example. The discussion starts with the symbol of capacitors. This is a schematic symbol usually used for indicating capacitors. It's inspired by 2 metal plates and the dielectric that exists inside any capacitor. These are 2 metal plates and there's air here as dielectric. This is simplest capacitor ever, but there is a very important point here. Contrary to the popular belief, this is not a symbol of a real capacitor indeed. Actually, this is a schematic symbol of an ideal capacitor, not a real capacitor. A real capacitor is something like this. Actually, there is an ideal capacitor inside a real capacitor, and there are hidden resistances and inductances beside the ideal capacitor inside a real capacitor. The main difference between different types of capacitors arises from the value of these resistors and this inductor. I mean, each type has a different range of values for these resistors and this inductor in different capacitances, which makes the capacitor suboptimal. The inner structure, manufacturing process, and the material used to build capacitors is the key factor which makes the value of ESR, ESL, and leakage resistor different and consequently makes different types different. It's not just ESR and ESL. The difference in the material and the manufacturing process affects other parameters as well. Parameters like cost, operating temperature, polarity, frequency rating, voltage rating, capacity, precision, size, durability, etc. This is why there are several types of capacitors. Indeed, they are different from several aspects. Some of them are superior to others from price or cost point of view. Some others are more durable. Some of them are more stable than others, and so on. I will talk more about these characteristics in detail later in this video, but for now, I think it's better to dive into the main subject. Let me bring you a well-known example. Capacitor type number 1, ceramic capacitors. Ceramic capacitors are the most popular capacitor type because they are general purpose capacitors. Their name comes from the dielectric used inside them. You can find them almost everywhere, from a cheap toy to a very high-tech device like a smartphone. These are THD ceramic capacitors and these are SMD ceramic capacitors. In these capacitors, the dielectric is made up of ceramic materials. They are used for several purposes. For example, in this board, I have used a bunch of ceramic capacitors near the microcontroller as decoupling capacitors. Look, I mean these capacitors here. Also, these are ceramic capacitors. Look at this old graphic card. There are plenty of ceramic capacitors on this board. Look here. And also these are ceramic capacitors here. And also these, and so many others. Moreover, there are ceramic capacitors here on this Arduino board. Look, there are several ceramic capacitors on this board. Another example is these capacitors at the DC motor leads. They are used for eliminating noises and spikes generated by the motor. You may ask, why are ceramic capacitors used there?
This is a good question, but the answer is simple. Keep this golden rule in your mind. You have to determine the required capacitance value, then consider the voltage rating, and you are done. In most cases, any type of capacitor will work. The question is about the performance. Which capacitor type will perform better than others in a certain condition? Anyway, these ceramic capacitors are general purpose and popular. They have their own advantages and disadvantages. They are cheap, easy to manufacture, small, non-polarized, operate at high frequency, durable, and have high voltage ratings. But on the other hand, they are inaccurate, unstable when the temperature changes, and have low capacitance. The advantages of ceramic capacitors are much greater than their disadvantages, and this makes ceramic capacitors popular and general purpose. Anyway, there are other types that have different pros and cons. Let's move on to the next capacitor type, which is very similar to ceramic capacitors. Actually, it's a kind of ceramic capacitors. Capacitor type number 2, multi-layered capacitors. As you know, these are ceramic capacitors. In a more precise classification, they fall into single-layered ceramic capacitors. So, we should have multi-layered ceramic capacitors too. Their main difference is clear from their names, right? But the main advantage of multi-layered ceramic capacitor over single-layered ceramic capacitor is in their quality, better electrical performance, and accuracy.
These are single-layered and these are multi-layered ceramic capacitors. As you can see, both of these capacitors are 100 nanofarad capacitors. This one is an ordinary single-layered ceramic capacitor and this one is a multi-layered ceramic capacitor. If I measure the capacity of multi-layered ceramic capacitor at 100 Hz, it seems okay. It's near the expected 100 nanofarad. But if I measure the ordinary low-quality ceramic capacitor, you can see that the capacity is not much accurate. I'm gonna measure the capacitance of both capacitors at 100 Hz, 1 kHz, 10 kHz, and 100 kHz to see how their capacitance changes at different frequencies. I'll also measure the ESR value to indicate the performance of the capacitors. As you can see, the capacitance value of a multi-layered ceramic capacitor is almost equal to the desired value 100 nanofarad, while the capacitance of a single-layered ceramic capacitor contains a huge error. This means that multi-layered ceramic capacitors have higher precision and are more accurate. On the other hand, the ESR value of multi-layered ceramic capacitors is always lower than that of single-layered capacitors, which means that a multi-layered capacitor is performing better than a single-layered one.
There are several factors to indicate the performance of a capacitor. ESR is one of them. The lower the ESR, the higher the performance of a capacitor. Multi-layered ceramic capacitors are more precise and perform better. So, in applications that need more precision and higher quality, multi-layered ceramic capacitors will be a better choice compared to single-layered ceramic capacitors. Note that it's not only the precision of the capacitance value that makes us choose a specific capacitor type. Sometimes the capacitance itself is the key. For example, in linear power supplies.
This is a transformer that is connected to main power to step down the voltage. I'm gonna set up the circuit and probe the output after the diode bridge. The output voltage is rectified by this diode bridge. This is a DC voltage now, but it's almost useless until it is not smoothed out by using a capacitor. Now that the output voltage is smoothed out by using a 10 microfarad capacitor, the output is nice and it seems smooth enough to be used in a DC circuit.
Yes, the output is smoothed out as long as you don't draw current from the power supply, because by drawing current from the output, ripples will come back. This is somehow normal. The higher the current you draw, the bigger the ripples will be. However, a 10 microfarad capacitor is very low in fact.
Now I'm gonna add an LED with a push button to see how it impacts the output. When the LED is off, the output is clear and smooth, but when I press the button, the ripples come back. There is a peak-to-peak 10 volts ripple in a 16 volts output. This is horrible.
To reduce the ripples, we need a capacitor with a higher capacitance. Ceramic capacitors are available with a maximum of 100 microfarad capacitance, which is still very low for many power supplies. Actually, we need a higher capacitance. Here is where the next capacitor type comes into play. Capacitor type number 3, electrolytic capacitors. Electrolytic capacitors are used where we need high capacitance. It seems weird, right? Because technically it's possible to make higher capacitance ceramic capacitors. You may ask, why don't manufacturers make high capacitance ceramic capacitors and instead they make electrolytic capacitors? Great question. Yes, that's technically possible to make higher capacitance ceramic capacitors, but in that case, other factors like cost and size will make ceramic capacitors inefficient and undesirable. In that case, electrolytic capacitors will be a good choice because they are small, cheap, and high capacitance at the same time.
These are schematic symbols of polarized capacitors, while this is a general schematic symbol of capacitors, including polarized and unpolarized capacitors. Electrolytic capacitors have polarity, meaning that they have a positive and negative lead in which the voltage has to be applied to it in the right polarity, otherwise the capacitor will be destroyed. These are electrolytic capacitors. Look, this white strip here indicates the negative lead. So this lead is negative and this one is positive lead. This is an axial leaded cylinder package. And this is in radial leaded cylinder package.
Everywhere you need a capacitor with high capacitance, a small size in proportion to its capacitance, and low price, you have to think about electrolytic capacitors. Electrolytic capacitors are cheap, have a high capacitance, but on the other hand, they are inaccurate, unstable when the temperature changes, polarized, have a low frequency rating, are not durable, have high leakage, and have low voltage ratings. Yes, being polarized is one of the major disadvantages of electrolytic capacitors because being polarized make this type of capacitors inappropriate for some applications where the polarity of the voltage changes over time. Let's look more closely at electrolytic capacitors to find out where these features come from.
I'm going to take apart this capacitor. Look, there are two metal plates inside the capacitor and a dielectric is separating the plates. The dielectric is impregnated with oil or something. There is nothing so special so far, but if you look attentively, you can see that these plates are covered with a thin layer of oxide, and this fact makes the electrolytic capacitors so special, make them have high capacitance and also make them polarized. As you can see, I have rubbed the metallic surface at this point using sandpaper to remove the oxide and make the metal shine. Actually, these matte colored areas are covered with oxide and these shiny areas are the aluminum itself.
When someone mentions an electrolytic capacitor, they are specifically referring to an aluminum electrolytic capacitor, while there is another type of electrolytic capacitors. Capacitor type number 4, tantalum electrolytic capacitors. tantalum electrolytic capacitors are almost the same as aluminum electrolytic capacitors, just the plates are made of tantalum instead of aluminum. There is no major difference between aluminum electrolytic capacitors and tantalum electrolytic capacitors because both of them are polarized. Tantalum is more expensive, tantalum is smaller, both of them have low voltage ratings, both of them have high capacitance, but tantalum has a higher capacitance in proportion to its size. Tantalum has lower leakage compared to aluminum electrolytic capacitors, and tantalum is more stable and durable. So you have to use tantalum electrolytic capacitor instead of aluminum electrolytic capacitor where the size and durability matters and the cost does that.
Look here, this is SIM 800L module. There is a tantalum capacitor here on this module. Here in this example, an expensive tantalum capacitor is preferred to an equivalent cheap aluminum capacitor because of size, actually to keep the module small and durable.
Moreover, tantalum capacitors are more durable and more stable. Since SIM 800L module and in general telecommunication modules have to be reliable and stable, we have to avoid using unstable and fragile components like aluminum electrolytic capacitors. You may ask, what does it mean if a capacitor is more durable or more stable? I'm going to start from durability. Since an oily material is used as dielectric in aluminum capacitors, with the passage of time and evaporation and drying that material, the capacitor loses its characteristics and function. Tantalum capacitors are more durable compared to aluminum capacitors. The next thing is stability, which is my favorite.
Stability means that in a harsh condition, the capacitor can retain its main characteristics, for example, its capacitance. Look, the capacitance of this capacitor is close to 34 microfarads, but when I hit it up, its capacitance increases, and when I cool it down, its capacitance decreases. Let me test another capacitor, this time a tantalum capacitor. Same thing happens to a tantalum capacitor.
A tantalum capacitor is not completely stable, but it's more stable compared to aluminum capacitors. In summary, tantalum capacitors are of higher quality compared to aluminum electrolytic capacitors, and consequently they are more expensive. In most cases, stability is not a big challenge. For example, in linear or even switching power supplies, a slight change in the smoothing capacitor will not affect the overall functionality of the power supply. But in some other cases, a small change in the capacitance of a capacitor can result in significantly malfunctioning of the entire device. In such a case, we have to use the next type of capacitors. Capacitor type number 5, polyester capacitors. Polyester capacitors are very stable, especially to temperature changes. Polyester capacitors are a kind of film capacitors. Film capacitors are divided into two main subcategories: paper film capacitors and plastic film capacitors. Plastic film capacitors are also divided into several groups according to the plastic material used in it as dielectric: polyester, polypropylene, polycarbonate, etc. All of these plastic film capacitors have similar features with a slight difference. So polyester capacitors are a kind of plastic film capacitors. Let's see what's so special about polyester capacitors.
This is simplest timer circuit ever. We have a button here, a resistor and a capacitor. When the button is pressed, the capacitor will be charged to VCC, and when the button is released, this capacitor will be discharged gradually through this resistor. So we have a decreasing voltage at this point here. The capacitance value of this capacitor has a direct relationship with timing. So we have to choose a stable capacitor to have a stable time. Suppose that this circuit here checks the voltage of this capacitor and turns this DC motor on if the voltage of this capacitor is not zero. These ceramic capacitors are not suitable type for timing because they are not stable, just like electrolytic capacitors that are tested before. Look, by heating up a ceramic capacitor, the capacitance value of the capacitor is increasing, and by cooling it down, the capacitance is decreasing. Then, if you use a ceramic capacitor here, the motor's on time will be dependent on the environment temperature, because by increasing or decreasing the temperature, the capacitance of this capacitor and consequently the on time of the motor will be affected.
In a sensitive application where you need a stable capacitance, a polyester capacitor will be a great choice because a polyester capacitor can retain its capacitance magically at different temperatures.
I'm gonna test this polyester capacitor. As you can see, the capacitance of this polyester capacitor at normal room temperature is about 100 nanofarads. If I cool it down, its capacitance remains constant. And if I heat it up, its capacitance also remains constant. Look.
Polyester capacitors are magical. By the way, capacitive dropper or capacitive power supply or transformerless power supply is another example where we need a stable capacity to ensure a stable output voltage. It's an interesting subject and I strongly recommend researching it. Anyway, polyester capacitors are relatively cheap. They are highly stable, they are reliable, they are versatile, they are durable, they are non-polarized, they have a high voltage rating and high frequency rating, but on the other hand, they have low capacitance and usually they are bigger than others. Actually, they are big in size proportion to the capacitance compared to other types like electrolytic capacitors or ceramic capacitors. Anyway, I said that polyester capacitors are stable, have a high voltage rating, and have a high frequency response, right? A high voltage rating along with high frequency response and stability makes plastic film capacitors suitable for snubber circuits.
A snubber circuit protects switches like semiconductor devices or loads from voltage spikes during switching process. It typically consists of a resistor and a capacitor to absorb or dissipate transient energy, enhancing device reliability in power electronic applications. Look at this snubber circuit here. This capacitor has to be able to withstand high voltages, respond to high frequency spikes, and retain its characteristics over time and at different temperatures. Plastic film capacitors are a good choice for applications like this.
The types of capacitors that are widely used for snubber applications include plastic film and ceramic capacitors. Whereas plastic film capacitors can be used for both high power and low power circuits, ceramic capacitors are mostly used for low power applications. Anyway, the next capacitor type is a bit nasty. Capacitor type number 6, MKT capacitors. MKT capacitors are nothing but polyester capacitors. The difference between ordinary polyester capacitor and MKT capacitor is in the manufacturing process. Yes, This little difference makes them different in characteristics, but they are not very different.
These are MKT capacitors. They act similar to polyester capacitors, and the dielectric in these capacitors is still polyester. For simplicity, MKT capacitors are a high quality version of ordinary polyester capacitors.
There are some other types like polypropylene film capacitors, MKP type, polycarbonate film capacitors, and much more, which are all plastic film capacitors, and they are very similar to polyester capacitors. I don't want to waste time on them in this video because nothing is so special about them. However, I recommend that you research them yourself. Anyway, capacitor types are not finished yet. There are several other types, each with its own pros and cons. I'm only content with introducing them. Capacitor types like paper capacitors, glass capacitors, mica capacitors, air or vacuum capacitors, supercapacitors, variable capacitors, etc. There may be even more other types, who knows? Anyway, we have reached the final moments of this video. Thanks for watching. If you enjoyed watching this video, please support the channel by hitting the like button and subscribing for future updates. See you next time.